Welcome on board.
They said, finally, we're so seasick.
They are. That's what we're after. What we've done in the past is just do a very simple study on shell thickness. Yeah, the shells are notably weaker, so these are really thin. So that's been our past work, which has now brought us back because we realize that these are, it's a little miracle that they're even living here.
They're living in places that you would normally think are hostile to them because of the low pH that dissolves their shells. But they have a way of protecting themselves and keeping their shells from dissolving by apparently building up a thicker organic layer on the outside of the shell.
The secret here is that these animals are struggling to keep themselves completely protected from the waters by their coat, like a little gold coat on the outside. If we removed this yellow, it's called the periostracum. It's an organic coat over the top. If we just scrape that off, you'd see the white shell underneath. But all of this white stuff, the calcium carbonate, is completely covered by either animal tissue on the inside or this gold layer on the outside. So it's never seen seawater. And what we've found is that the moment any white is exposed, it dissolves immediately in these pH waters.
You see this really extreme case here at Northwest Daifuku where you have nearly pure CO2 coming out, and that's really driving all the chemistry at that volcano. So it's quite interesting to use those volcanoes to study how animals maybe can adapt to lower pH, or which species will survive, to get a peek at what the future ocean might look like. Because of all the building CO2 in the atmosphere, the pH of the surface ocean is dropping by about 0.2 pH units per 100 years.
And the big concern has been what we call ocean acidification. So as CO2 goes into the water, it changes the whole balance of the carbonate chemistry.
This particular species of mussels that we find at this volcano is adapted to living in low pH, high CO2 environments. In fact, they only are in the low pH environments because that's where they're getting their energy from. They're getting their energy from chemosynthetic organisms that are symbionts within the mussels that take advantage of the hydrogen sulfide and other reduced compounds that are in the plumes that are coming out of these vents.
So this is the big gill, the big brown thing is the great big gill that has all the symbionts inside it. So that's how it makes its food. So they got this trade-off. It's a really great place to live for their food source, which comes from the bacteria. On the other hand, it's a lousy place to live if you want to make a shell. It's a trade-off. Everything in life's a trade-off, right?